Hello students, in this module let us learn about the elements of symmetry in organic chemistry. This is useful for the students of grades 11 and 12. Please subscribe my channel, like, share and comment my videos.
Elements of symmetry. Elements of symmetry in chemistry. There are four elements of symmetry in chemistry, especially as we are discussing organic chemistry. Now let us try to understand the elements of symmetry of organic molecules. The first one is center of symmetry. The first one is center of symmetry, or this is also referred as a inversion center. This is also referred as a inversion center, represented by Ci. The second one is plane of symmetry. Plane of symmetry. Plane of symmetry or sigma plane. Sigma plane. The third one is proper axis of rotation. Proper axis of rotation. And the fourth one is improper rotation. Improper rotation. Improper rotation or rotation followed by reflection. Now let us discuss about the first one after the other in detail. The first one is center of symmetry. Center of symmetry. Who is center of symmetry? Center of symmetry or inversion center of a molecule is such a point in the molecule which is equidistant from same atoms or groups which orient, same atoms or groups which orient on opposite sides of the molecule. Opposite sides of the molecule, or it is also referred as, or center of symmetry is such a point in the molecule from which an identical atom or group, which exists diametrically or diagonally opposite to this point, an equal distance from it. Now let us try to understand this center of symmetry with an example. So here this is CH3, chlorine, and of course this is hydrogen. This is CH3 and here chlorine, this is bromine. So what is the name of this substance? The name of this substance is, this is carbon, this is methane. So 1, 2, 3, 4. Therefore this is butane. On butane, this is a hydrogen. On butane, chlorine atoms are present on second and third carbon atoms. Therefore this is a 2,3-dichlorobutane. And what is a geometrical isomerism? This is a trans means staggered, right? Now imagine to join the identical atoms or groups. So this is CH3, CH3, CH3 groups are joined together, and of course this is a hydrogen joined together. This is chlorine joined together. So this is the point at the center of the molecule, and from this point two identical atoms, chlorine atoms, are at equal distances from this point. Similarly, hydrogens are at equal distances and methyl groups are at equal distances. Therefore, such a point is referred as a center of symmetry. So, the center of symmetry means center of symmetry or inversion center of a molecule is such a point in the molecule which is equidistant from the same atoms or groups which orient on opposite sides of the molecule, or an identical, the center of symmetry or inversion center of a molecule is such a point from which an identical atom or group which exists diametrically or diagonally opposite to this point an equal distance from it. So that is a center of symmetry. Now let us take one more example for this center of symmetry. One more example of a molecule of this center of symmetry. So this is a hexagonal ring. Nitrogen here, and this is C double bond O, hydrogen CH3, here hydrogen CH3. So what are the diagonally opposite groups? Here this is hydrogen, this is hydrogen. So hydrogen atoms and both the nitrogen atoms are opposite to each other, therefore imagine to join these two. Similarly, the carbonyl oxygen atoms joined together, and hydrogen atoms joined together, and CH3 groups joined together. So all the same groups are equidistant from this point at the center of the molecule, center of the hexagonal ring. Therefore this is referred as center of symmetry. Center of symmetry. Center of symmetry or inversion center can be explained by taking an example of a molecule. This molecule is 2,4-dimethyl cyclobutane 1,3-dioic acid. So this substance is 2,4-dimethyl. So here this is one methyl group, this is one methyl group. So if we give the numbering from this side, this is number 1 carbon, number 2 carbon, and this is number 3, this is number 4 carbon. So methyl groups are present on 2nd and 4th carbons, and carboxylic acid groups are present on 1st and 2nd carbon atoms. So what is the center of inversion? Center of inversion or symmetry center is a point, an imaginary point exists in the center of the molecule from which the distances of equal atoms are groups. So here the equal atoms, here COOH group and here this is COOH group. Therefore the COOH groups, let us join the COOH groups in this manner, and of course let us join the CH3 groups. So this is CH3 groups in this manner. So here this is the point which exists at the center of the molecule. Now imagine to join the similar groups. So this hydrogen which lies above the plane is joined with hydrogen which lies below the plane in this manner. Similarly, the hydrogen which lies below the plane in this manner is joined with the hydrogen which lies above the plane in this manner. So this point is known as center of symmetry or inversion center. So this is center of symmetry or inversion center for this molecule 2,4-dimethyl cyclobutane 1,3-dioic acid. Now let us learn about the plane of symmetry. What is plane of symmetry? Plane of symmetry means an imaginary plane that divides the molecule into two equal halves such that each one half is the mirror image of other. Each one half is the mirror image of other. Now let us try to understand this with some examples. See here, examples. This is cyclobutane. Here hydrogen, this is CH3, and here hydrogen, this is CH3. So this is giving the numbering to the carbon atoms 1, 2, 3, 4. Therefore the name of this substance is 1,2-dimethyl cyclobutane. 1,2-dimethyl cyclobutane. So here imagine to draw a plane here. So this plane, this is a plane. This plane divides the molecule into two equal halves, of which each one is the mirror image of the other. Therefore this is a plane of symmetry. So this plane of symmetry is also referred as sigma plane. Plane of symmetry is also referred as a sigma plane. So this sigma plane, this is a vertical. So here in this example, the sigma plane is vertical plane. Now let us take one more example. This is again cyclobutane here. So this is hydrogen, chlorine, and of course this is hydrogen, chlorine. So what is the name of this substance? If you start the numbering of the carbon atom which bears chlorine atom, this is 1, 2, 3. Therefore this is 1,3-dichlorobutane. So here imagine to draw a plane which joins the vertices of the molecule, vertices of this figure. Therefore this is a plane of symmetry. So this plane of symmetry, here sigma plane is diagonal. Now let us see another example with a different substance. This is CH3, this is CH3. Here is one carbon atom, here is one carbon atom. Therefore the number of carbon atoms here are 4. So this is OH, this is also OH, hydrogen here. So what is the name of the substance? 1, 2, 3, 4. Hydroxy groups are present on second and third carbon. Therefore this is the long chain is butane 1,3-diol. Imagine to draw a plane which divides the molecule exactly into two equal halves. Therefore each one is the mirror image of the other. So here the sigma plane is plane of symmetry, or sigma plane is horizontal. Therefore, the sigma plane or plane of symmetry can be vertical, horizontal, or diagonally or diametrically. Now let us take the example of a plane of symmetry in another molecule, that is benzene. So benzene molecule is here. This is the benzene molecule C6H6. This is C6H6. So here, what are the planes of symmetry? One plane passing through the molecule. One is horizontal plane. One is the horizontal plane or molecular plane. So planes of symmetry. Planes of symmetry of benzene. One is horizontal plane. Horizontal plane. Or it is also called as molecular plane. Molecular plane. And 6 vertical planes. 6 planes, sigma planes passing through. Here what happens? A set of 3 planes. A set of 3 planes passing through the hydrogen atoms. Passing through the hydrogen atoms. That is, see here. This is one plane here. This is another plane, and this is another plane. So therefore, the set of these 3 planes joining the hydrogen atoms of the benzene ring. So another set of another set of 3 planes passing through the midpoints of sides of a hexagon. So benzene molecule has totally 7 sigma planes. Benzene molecule has 7 sigma planes. Let us see one more example for sigma plane. Chloroform. What is the formula of chloroform? CHCl3. So this is a chloroform, hydrogen here. This is chlorine, and of course this is chlorine. Now imagine to see, this is a tetrahedral structure. So tetrahedral structure looks in a different manner on a 2-dimensional plane of the paper. So imagine to draw a plane along hydrogen and each chlorine atom. So along this plane, the molecule is divided into 2 equal halves. Therefore, the plane of symmetry. What is the other name of the plane of symmetry? Sigma plane. So plane of symmetry or sigma plane is the plane passing through hydrogen atom and any one of the 3 chlorine atoms. Therefore, there are 3 sigma planes for CHCl3, that is a chloroform. Now let us discuss another element of symmetry, that is axis of rotation. Axis of rotation or simple axis or proper axis of symmetry. Now how do we define axis of rotation? An imaginary line or axis passing through the molecule, about which it is rotated through an angle of an angle of 360 by n gives an orientation similar to the original one. So an axis of rotation is an imaginary plane or axis passing through the molecule about which it is rotated through an angle of 360 by n gives an orientation similar to the original one. Now let us try to understand this with an example. Boron trifluoride BF3. So this is BF3 is planar. The shape of the molecule is planar. Imagine to join an axis perpendicular to this plane. Right. So an axis perpendicular to the plane. Now rotate the molecule through 120 degrees. Therefore we get the similar orientation. Therefore now here 360 by n equal to 120 or n equal to 3. Thus this axis of rotation is referred as C3. Therefore the axis of rotation in general axis of rotation is represented as Cn. N for number. What is n? N is the number of times that the similar orientation obtained during the rotation of 360 degrees. Therefore for boron trifluoride the axis is C3 axis. Now let us take one more example. Example 2. This is cyclobutane, hydrogen CH3, hydrogen CH3. Of course here they are hydrogens. We need not represent this. If any atom is not represented, it is understood that they are hydrogens. Now imagine to have a line or axis passing through perpendicular to the plane of this plane of the molecule. Now if it is rotated through 180 degrees, we get the similar arrangement. So here this is hydrogen CH3, hydrogen CH3, hydrogen here, hydrogen. Therefore what is the name of this substance? The name of this substance is 1,2,3. So 1,3-dimethyl cyclobutane. 1,3-dimethyl cyclobutane. So 1,3-dimethyl cyclobutane has a C2 axis. Now let us take another example. CHCl3. This is a chloroform. CHCl3 chloroform. You can take even methane or CCl4 also. So the chloroform structure, this is hydrogen, C, chlorine. Now imagine to have a line or axis of symmetry passing through hydrogen atom. Now if we rotate through 120 degrees, then a similar orientation is obtained. Therefore 360 by n equal to 120 and n equal to 3. Therefore CHCl3 has C3 axis. C3 axis means in a rotation of 360 degrees angle, the number of similar arrangements obtained is 3. In elements of symmetry, The third one is improper or alternate or reflection axis. Now let us try to understand this with an example. Tartaric acid. Tartaric acid. The formula of tartaric acid, COOH. This is COOH. Here is one carbon. OH, H, and this is HOH. Now the Sahar's projection can be written as this is C2C3 bond is drawn with a straight line in a slightly tilted manner, HOH, and here this is COOH, and the other carbon atom COOH, and this is OH, this is H. So this is a Sahar's projection. Sahar's projection. What is this orientation? This is a staggered orientation. Staggered means the similar groups are far away from each other. OH and OH, hydrogen and hydrogen, COOH and COOH, they are far away from each other. Now let us write this separately once again here. This is hydrogen, OH, COOH, this is COOH. Now rotate this through 180 degrees angle. This is 180 degrees angle. Right here the rotation means this is the axis of rotation. The axis of rotation is in this manner. So rotate this through 180 degrees like this. So if you rotate this through 180 degrees, the structure comes in this manner. So here this COOH comes here, COOH, and this hydrogen comes here, and OH comes in this manner, and this COOH comes up here in this manner. This is COOH, and this is OH here, this is OH. So this is a structure obtained after rotating this structure, this projection through 180 degrees. Now imagine to keep a mirror. What is the position of this mirror? See, this is the rotational axis, rotation axis. So the rotation axis over this, the mirror is kept in a perpendicular manner in this way. The rotation is kept in a perpendicular way, or otherwise this is the rotation of axis and this is the perpendicular to the mirror in this manner, right? So like this is a rotational axis and this is the mirror perpendicular to this. Now if you keep a mirror, we can observe the image. How this image is observed? This is the image is observed in this manner, H, OH, and of course here, and this is COOH, this is OH, and this is hydrogen. See here in this is a structure obtained after rotation followed by reflection. This structure is similar to this structure. So in such case, this process is known as improper process. This is improper process or alternate process or rotation reflection process or rotation reflection axis. Now let us try to understand this with a three-dimensional model. So this is COOH, this is COOH, this is OH, this is hydrogen, this is OH, this is hydrogen, this is OH. Now imagine to rotate this through 180 degrees angle. So this structure is same as this one. So keep this as original structure and rotate through 180 degrees. This is 90 degrees rotation and this is 180 degrees rotation. So this is the structure obtained after rotation through 180 degrees. Now imagine to keep a mirror in this manner. So if you imagine to keep a mirror and of course observe the mirror image. the mirror image is obtained in this manner. So like this. So the similar groups imagine similar groups are reflecting. So this is OH and this is OH. Now what is the structure? This structure is similar to the original structure. So this process is known as a improper process, improper or alternate process or alternate axis. Now once again here, this is tartaric acid and rotated through 180 degrees, and here the structure obtained after reflection in the mirror. Let us see the definition. An improper or alternating or rotation reflection axis of symmetry of order n. N means number of times repetitions obtained in a rotation of 360 degrees angle. Number of repetitions obtained through rotation of 360 degrees angle. So this is order n. Sn can n-fold axis such that a rotation of 360 by n around it followed by reflection in a plane perpendicular to the axis generate a structure indistinguishable from a original one. Therefore, after rotation through certain angle, the structure obtained is observed in a mirror. The image observed in the mirror is original to the first one. So such an angle is known as an improper axis or alternating axis or rotation reflection axis. So here n, if you keep 180 degrees, then you can find 2 times the original substance is obtained. That means after rotation of 180 degrees and after rotation of 360 degrees, the original structure obtained twice. If you rotate through 120 degrees, 3 times the original substance, original orientation is obtained. If it is rotated through 90 degrees, then 4 times the original orientation is obtained. If it is rotated through 60 degrees, then original orientation is obtained 6 times. So this is improper rotation. And of course another example here is, this is 1,3-dichloro 2,4-dimethyl cyclobutane. So this is rotated through 180 degrees. The structure obtained in this manner. This CH3 group is obtained here, CH3. This chlorine is obtained here, this chlorine. And of course this chlorine is obtained here. Now it is observed in a mirror. The mirror image is this. So the mirror image is similar to the original. So such a process is known as an improper process. We discussed about the S2 operation. In S2 operation, the molecule is rotated through certain angle and the orientation so generated is observed in the mirror plane. So let us take an example. This is cyclobutane structure, and here this is a hydrogen CH3, COOH hydrogen, this is a CH3 hydrogen, and here COOH hydrogen. So what is the name of this substance? Name of the substance 1, 2, 3, 4. Methyl groups on second and fourth carbon, therefore 2,4 dimethyl cyclobutane 1,3 dioic acid. 1,3 dioic acid. Now this is rotated through 180 degrees. So axis of rotation is 180 degrees. When it is when the molecule is rotated through 180 degrees, what happens here? The groups are exchanged with opposite atoms. So this number 1 carbon becomes number 3. So here this becomes COOH, and 2 becomes 4 hydrogen CH3. 1 becomes 3 becomes 1 here. This is COOH hydrogen, and 2 becomes 4. So this is CH3 hydrogen. So this is rotated through 180 degrees. Now this is observed in mirror plane. So this is mirror plane. When it is observed in mirror plane, see here, this becomes a hydrogen CH3, and here this hydrogen is seen here. and of course COOH, and this is observed in this manner. Here it is CH3 hydrogen, and here this is COOH is observed here. Now this is the mirror image. Mirror image. This mirror image is similar to this original orientation. Therefore, the molecule has S2, that is S2 axis. Then this operation is known as S2 operation. S2 operation. Now imagine to join the opposite groups on similar groups on opposite sides. So this is COH is joined here, CH3 is joined here, hydrogens are joined here, and these hydrogens are joined here. Therefore, the similar groups, the same groups on opposite sides are equidistant. Opposite sides are equidistant from the point, and such point is called center of inversion. Center of inversion. So here this molecule has S2 operation and it has center of inversion. Therefore, S2 is equated to Ci, that is improper axis of rotation, that is S2 is equated to Ci, that is center of inversion. Similarly, S1 operation means the molecule is rotated through 360 degrees, and of course the orientation thus obtained is observed in a mirror plane. S1 operation has two components. S1 operation has two components. What are those two components? One is C1 and another one is sigma plane. One is C1 and another one is sigma plane. C1 operation of the molecule leaves the molecule unchanged. So leaves the molecule unchanged. Unchanged means there is no difference in the orientation. Therefore, C1 operation is referred as identity operation. C1 operation is referred as identity operation. And what is left? This is a sigma plane. So therefore, S1 operation is equated to sigma plane or sigma operation. Thus, instead of looking for S1 and S2 operations, since one has to look very carefully for S1 and S2 operation, so instead of looking for S1 and S2 operation, one has to look for Ci, center of inversion, and sigma plane. So if we check for C1 and sigma plane, then it is understood that they possess even S1 and S2 also. If the molecule does not have Ci and sigma plane, that is S1 and S2 are not present, then we have to look for Sn operation. Means n is greater than 2. N is greater than 2 means S3, S4, S6 operations, etc.
In the next module, let us learn about the optical isomerism. Please subscribe my channel, like, share and comment my videos. Thank you.